All right, so we start our new unit today. Our new unit is about trigonometry, which sounds a lot harder than what it is. It's not bad. So we're going to start by discussing right triangle trigonometry. So right triangle trigonometry is a branch of math that deals with the relationship. So this first blank is just relationship. Relationship between the sides and angles of a, what kind of triangle do you think we're talking about?
Right triangle.
Oh, y'all are so smart. A right triangle. So right triangle trigonometry, or just, you could say trig. You don't have to say trigonometry. We can call it right triangle trig. It's a branch of math that deals with the relationship between the sides and the angles of a right triangle. I'm not going to ask you to regurgitate that information to me. I don't care that you truly know what it means, because we're going to, learn about it and you'll know how to use it, so you don't need to regurgitate the definition of that to me. All right, so we need to talk about the trig ratio. What does it mean to be a ratio?
Fraction.
A fraction. Nice job. A fraction. A ratio is just a fraction. And we're going to learn about 3 trig ratios. So a trig ratio is the ratio, or the fraction, between the sides in a right triangle. The trig ratio is a ratio between the sides in a right triangle. So we'll have 3 different trig ratios we're going to talk about: sine, cosine, and tangent. But before we do that, let's look over here at our right triangle. This one. All right. We need to label our right triangle. Let's go ahead and label the hypotenuse. Where's the hypotenuse located? Across from the right angle. So this is my hypotenuse. This is my hypotenuse. Hold on just a second. Okay, so remember we talked about on Thursday, Miss Boyd was in a sorority. Do you remember that?
Yeah.
Yes. What sorority was I in?
Theta.
Theta. All right, I was a theta. Why did we talk about that, though? Why did it matter?
Because of the sign.
Because of the sign, right? What is the sign? What did we say theta sign is?
Like an oval with a line through it.
Yeah, it's an oval with a line through it, right? So, like that. All right, we talked about this because that is our reference angle. That's how we represent a reference angle. It's with a theta. All right, so in a normal right triangle, we would label those other 2 sides as legs, right? But because I'm talking about my trig ratios, I need to be a little more specific. So we're either going to label them as the opposite side or the adjacent side. What does it mean to be adjacent? Right beside, next to, something like that, right? So this is going to be the adjacent. For that blue reference angle, this is the adjacent side because it's the one that's next to it.
Next to what?
That reference angle.
What is the reference angle?
The theta.
Oh, so like when the reference angle, like, it's always gonna be beside the adjacent.
Yes. Yeah. The reference angle is always going to be right beside the adjacent. Yeah. All right. And so that means my other side is the what? Yeah, very good. The opposite side. The opposite side. All right. But it matters depending on which reference angle you're talking about, because in a right triangle, you'll have 2 reference angles, or you could have 2 reference angles. Your right angle will never be the reference angle because it's not changing size, right? It's not going to change size because a right angle always measures how much? 90. So because it's not changing size, it's never going to be my reference angle. So I could have that blue reference angle, or I can have the red reference angle. So if you have like a pen or a different color, something you can write with, you might want to do this with a different color. But if you don't, I wouldn't write anything. I would just watch, okay? So if you have something that's a different color, you could write with a different color. But if you don't, just watch. Even if you're just going from pencil to pen or something like that. All right. So all the sides I labeled in blue, and they were according to that blue reference angle, right? Yes? Okay. How would it change? How would my triangle change if I'm talking about in reference to that red theta or the red reference angle? How would my labeling change?
The opposite would turn to the adjacent, and the adjacent would turn to the opposite.
Very good. My opposite and adjacent would switch because now the side that's adjacent to that red one is this one. And the side that's opposite is this one. So your opposite side and your adjacent side depend on the reference angle. Your opposite side and your adjacent side depend on the reference angle. So that's actually a blank we're going to fill in as well. The opposite side and the adjacent side depend on the reference angle.
You have to write this in a different color? Reference angle?
No, I'm just not switching my pen back. You can write in whatever color you want.
Both?
I'm just not switching my pen back. I'm just going to stick to red for now.
Is that all we're gonna need the other color for?
Yeah, that's all you need the other color for. Unless you want it later while you're doing your work, but you'll be okay if you don't have it. All right, and the hypotenuse is always located across from the what? The right angle. That's never gonna change, right?
No.
Thank you. Okay, so let's go back to our 3 trig ratios. Or do we all need a second to finish writing? I'm sorry, I didn't even ask. Okay, I'll give you a second to finish writing. Yes, sir.
So the reference angle, like, I'm kind of confused.
That's okay. The reference angle is just whatever angle you're talking about.
So the angle, so like adjacent side and opposite side, how you determine which one is it?
Depending on which angle you're talking about. So we're about to look at an actual example with like numbers and stuff, and I think it'll make a little more sense then. If it doesn't, then let me know, okay? All right, so let's talk about our 3 trig ratios. So if it's a ratio, I need a fraction, right? So I'm going to need 3 fractions. So my sine fraction is the opposite side over the hypotenuse. I'm going to abbreviate from here on out. Opposite is OPP, adjacent is ADJ, hypotenuse is HYP. I'm just using the first 3 letters of each word.
Are we allowed to do that as well?
Absolutely. You can even just do O, A, and H. I don't care. Just something so you know what it means. That sine is the opposite over the hypotenuse. You're filling in right there where it says trig ratio and it says sine. It's just the opposite over the hypotenuse. Your cosine is the adjacent over the hypotenuse. That's really bad. I messed up that y real bad. Oh well.
What? That's not a lot.
It is a y, HYP. I just messed it up real bad. And then tangent is opposite over adjacent. Opposite over adjacent. So I will expect you to have all 3 of these memorized, but I'm going to teach you a trick on how to memorize them. How do you remember your order of operations?
Wait, what are they?
Put those cards away. Put the cards away. Put the cards away.
What are
All right, wait. So I heard 2 different ways. So what is one way you remember your order of operations? Okay, PEMDAS. And Mike, what did you say? Please excuse my dear Aunt Sally. Yeah, it's the same thing, right? So PEMDAS is what we call an acronym. It just takes the first letter of each word and we put it together to make something else, like NASA. NASA actually stands for National Aeronautics Space Association or something like that, right?
Yeah.
Something like that. Okay, but we shorten it down to NASA, right? So a acronym that we can use to help remember this is, hold on, I'm trying to get a different. Okay. SOHCAHTOA. So SOHCAHTOA, sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent.
Can you write those to like the side where they go?
What do you, like here?
Yes, like where is this OH? Like,
Sine. This one goes to this one.
oh, okay.
This one goes to that one. This one goes to that one. So SOHCAHTOA. So that is our, what did I call it? An acronym to help us remember this. Or the other one, please excuse my dear Aunt Sally, is what we call a mnemonic device. It's like a funny sentence that we use to help remember things. So thanks to Mr. Castello, I now know a funny sentence for this. Are you ready?
Yeah.
Some old hag came around here tripping on acid. Some old hag came around here tripping on acid. When you see Mr. Caslow in the hallway, you say thank you for our funny sentence. He taught me that.
Now I'm gonna say what's up to the
Someone.
Some old hag, just meaning some old lady, right? But it's a mean word for a lady, came around here tripping on acid. But I remember SOHCAHTOA. And that's the way most people remember it is SOHCAHTOA. But you remember it how you need to remember it. All right? All right. Uh-huh. That's what I think too. All right. Let's look at an example. So let's scroll down and look at our example. All right. So we've got numbers 1 through 6. But if you notice on 1 through 3, there's a certain letter in the parenthesis, and 4 through 6, there's a different letter, right? What is our first letter?
A.
A. So that letter that's in the parentheses represents our reference angle. So let's just look at 1 through 3 right now, since they have the same reference angle. So I'm looking at angle A, and I'm going to label my triangle accordingly. So where's my hypotenuse? At 5, because that's the side that's across from my right angle. Where is my adjacent? At 4, very good. Because it's the side that's next to my angle.
What's your angle?
A.
Oh, okay.
C is not an angle?
Not yet. We're not looking at it yet.
C is gonna be your sorority name.
No. A is for right now, because whatever letter's inside the parentheses is the angle I'm looking at. So we're just looking at numbers 1 through 3 right now.
Oh.
Yeah.
Oh, true.
We're going to get there in just a second. But we're only looking at numbers 1 through 3 right now.
Okay, yeah, I got it now.
Okay, so that forces which one to be my opposite?
5.
3. Very good. Okay, so sine is opposite over hypotenuse. So what is the opposite side? 3 over the hypotenuse is 5. And that's it. That's your answer. 3 over 5 is your answer. Because I just substituted into the ratio that I know.
There's 3 and then.
Okay, they easy boy.
Yeah, it's not bad. All right, so let's look at cosine. So cosine is my adjacent over hypotenuse. So what is the adjacent side? 4. And the hypotenuse is 5. Very good. And then my tangent is opposite over adjacent. What is the opposite?
It's 3 over 4.
3.
3 over adjacent is 4, and that's it. Those are your answers for that part. Okay. All right, so now let's look at 4 through 6. Now my reference angle is what? C. And how does that change my blue triangle? What do I need to change?
C and
Yeah, the adjacent and the opposite. So I'm just going to swap them, right? Because now what's adjacent to C is that number 3. And what's opposite is the number 4. But I still fill it out, using those same ratios. So sine is still opposite over hypotenuse, but what's the opposite this time?
4.
What?
4.
4 over 5.
So just everything flips
Yeah. The adjacent is now
on top.
3, so this is 3 over 5, and the opposite tangent is opposite over adjacent, which is 4 over 3. Very good. All right, look at number 6 for just a second. Let's look at number 6 for just a second. That kind of fraction that we wrote is what is called what? An improper fraction. In your whole math career up till now, you've been told that you need to fix improper fractions, right? That you need to change it to a mixed number, that nobody likes improper fractions, that they're gross, you need to get rid of them, right? I love an improper fraction. You leave it. You don't change it. Because if you change it to 1 1/3, I don't even know what that means. You leave it as 4 over 3. Isn't this easy? All right, so let's do, show me with your thumbs. Thumbs up, I know what I'm doing. I probably don't need Miss Boyd anymore. Thumbs in the middle, I'm getting there, and after another example or two, I won't need her. And thumbs down if we have no idea what we're doing.
I still need more, but I
Okay, what questions do you have?
Like, I'm still confused about, like, you don't remember how you, like, flip it, you, like, switch?
Yeah.
That's the only thing.
Okay, so what confused you is how to know when to flip them? It depends on what is inside the parentheses. So for numbers 1 through 3, A was in the parentheses, right? So that's the angle I'm looking at. So I've got to determine what is the adjacent side for that specific angle. And what is the opposite side. So those were my blue ones, right? Up on the board, those were my blue ones. Okay? And so then when it swapped, that now C is my reference angle, well, that blue opposite side is no longer opposite to that red angle, right? Because opposite means across from. Instead, now it's right next to it.
Oh.
So I've got to change that to be adjacent because that 3 is now right beside my C.
Yes, ma'am.
Does that make a little more sense?
Yes, ma'am.
Are you just saying yes?
It's like, so, I'm just making sure, like, if it's next to the letter is like adjacent.
Right. If it's next to the letter you're looking at, then it's the adjacent.
Yes, ma'am.
Mm-hmm. Very good.
It's not a threesome.
Okay, did anybody else have any other questions? Any of my friends who's like somewhere in the middle, did we have any questions? Or do we just need a few examples?
I'm still confused on like how you're gonna like.
No. Ask your question. It's okay.
I think I've got it. It's just sometimes confusing.
Okay, do you want to do one more example and then see if you need to ask your question?
Yeah, sure.
Okay, let's try one more and then see, okay? All right, so let's flip our paper and we're all going to look at number 1 together. So we're flipping our paper and we're looking at this number 1 together. All right. So the first thing I need to do is look at what letter is inside my parentheses. So for number 1, what is my reference angle? A. Very good. I always start out by labeling my triangle. Before I do anything else, I'm going to label that triangle. Even currently, even though I've done a million of these problems throughout my lifetime, I still label my triangles so that there's no chance that I confuse myself. Okay? So across from my right angle is the hypotenuse. The side that is next to, or that is touching that angle, is called the what? Adjacent. So that 9 is going to be the adjacent, because that is what is next to my angle that I'm looking at. It's the side that's touching my angle that I'm looking at. Opposite is like repelled, right? Opposite means like across from. And so that's going to be that 12. So now we're going to start with our ratios. The sine ratio is opposite over hypotenuse. So what is the opposite for this one? 12 over what is the hypotenuse?
15.
All right, reduce my fraction though. 12 over 15 is actually what? Thing.
1 over 3.
No, hold on.
2 over 3.
Yeah, 4/5, because they both reduce by 3. 4/5. If you remind me tomorrow, we'll have calculators. Hey, pay me attention. If you remind me tomorrow, we'll have calculators, and I'll show you how to do this in your calculator if you can't remember how to like reduce the fractions. It's a click of like 2 buttons, I think.
I thought we weren't simplifying. I thought you were doing it.
No, I want it simplified. I don't want it as a mixed number. So like instead of changing that 1 that was 4 over 3 to 1 1/3, you just leave it as 4 over 3. But because I could reduce this fraction, we're just going to reduce the fraction.
So we have to simplify.
Yes. Yes, you need to simplify.
That's not my strong suit.
That's why I'm going to show you how to do it in a calculator. I'm going to show you how to make the calculator work for you. Okay? All right, the cosine is adjacent over hypotenuse. What is the adjacent?
9.
Over.
15.
Reduce it. 3/5.
Where are we getting 3 from if it's cute?
It's cute.
If it's cute. No, that's a 9, honey. Okay, wait, no, but to be fair, it kind of does look like 1. It kind of does look like 1. Okay. All right, tangent is opposite over adjacent. What is the opposite? 12 over the adjacent is? Reduce it. 4/3. Leave it as 4/3.
You know?
It does. I'm with you.
Oh my gosh, y'all.
All right. I want you to try number 2, because number 2 is very, very similar to number 1. So you're going to try number 2, and then as soon as you're done with number 2, put your pencil down. Even if you've already moved on, I need you to put your pencil down so I know where we're at.
I just messed up.
It's okay.
Oh, wait, go back.
Oh, I'm sorry. Hold on. Here we go. I'm sorry.
Alright, you can get this.
Okay. All right, so we're doing number 2, and I'm going to give you like a minute to get it done. Mary Claire, put it away.
She's in the
Oh,
calculator.
okay.
Turn it sideways. Dude, your phone is like zooted. Don't fear.
All right, are we good?
No.
Yes, boys.
Yes, ma'am.
I need Slate and Martha for checkout.
Yes, ma'am.
Thank you.
number 2. All right, so for number 2, what is my reference angle? F. The hypotenuse is 20. The adjacent is, and the opposite is, very good. All right. So the sine is opposite over hypotenuse. What is that? 16 over 20, reduce it. 4/5. Cosine, adjacent over hypotenuse. What are the numbers? 12 over 20, reduce it. And then opposite over adjacent. Reduce it. Beautiful. All right. All right, let me see. Vote with your fingers. 1, easy peasy, lemon squeezy. 5, difficult, difficult, lemon, difficult. A 3 is like a medium, medium, lemon, medium.
What if it's a 0?
Well, then it would be a 1 because it's still easy peasy. All right. So I will be right here if you have any questions. You are doing the rest of this worksheet, and numbers 5, 6, 7, and 8 are your checkpoint. It will be uploaded here in just a second to Summit. 5, 6, 7, and 8. And if you need to check your answers, it's hanging right there. Right there.
So we don't have to do whatchamacallit?
No, you don't have to do 3 and 4 if you're feeling good about it. Yeah. I'm still going to do 3 and 4 up on the board, but you don't have to. Are you checking your answers, though? Do you know what you're doing?
I kind of do. What I get confused at is the, like how you like put it 12 over 20. How do you find it?
Like, how do I... All right, guys, now numbers 5, 6, 7, and 8 are your checkpoint. 5, 6, 7, and 8. So complete these, upload a photo of them to your checkpoint, and you're done.